This is the video demo for the generic assembler. The generic assembler takes in two files, a specification file of a computer architecture and an assembly file for that computer architecture. So I'm going to show you two examples. The first one is for a RISC architecture, which is MIPS, and the second one is for a CISC architecture, which is x86. So here's a MIPS specification file. It's broken up into sections. The first section specifies the name of the architecture. The next section, register, specifies the register names and their encoding values. The next section specifies the instruction formats needed for the architecture. So the first one is called itype, and that has 4 fields: opcode, RS, RT and immediate. Opcode is 6 bits long, etc. The assembly op tree describes the arrangement of operands in the assembly language. So what it says here is that an assembly statement is of the form mnemonic and 0 or more operands. So an operand can be a register, immediate or a label. That's a data label or a relocation point label. An immediate is a hex value, and so on. The mnemonic data section specifies the field encodings for a particular mnemonic. So for the first one, ADU, the opcode field is always encoded with this value here in binary. This line says that the expected operand arrangements for that mnemonic is mnemonic, reg, immediate. And the first register gets encoded into field RT, the second register gets encoded into field RS, and the immediate value gets encoded into field immediate. And itype instruction is used to encode this one. The endian for the architecture is big, and the minimum addressable unit of the architecture is a byte, 8 bits. So I've prepared a hello world program for MIPS. Here it is here, and I'm now going to assemble it. So that will generate two files in our directory: objectcode.txt and specerrorreport.txt. So we'll check if there's any errors in the spec file. No errors, so let's check the object file. And you can see the object code there. On the left before the colon is the memory address, assuming it starts at address 0, and on the right is the binary in hex form. So just to make sure that's right, I'm going to look at the encoding using a real MIPS assembler. So this is hello world here. These are pseudo instructions which are converted to the same instructions that you saw. So as you can see here, the values are the same, 24020040 and so on. Next I'm going to show you an x86 specification file. This is a lot more complicated because it's a CISC architecture. I'm not going to go through it all, but it's all detailed in the manual how you do this. And the main point here is that the add instruction can take many different forms. It can take, 2 registers or any one of these operand types down here. So here's an assembly file for the x86, and you can see all these different types of add instructions here. So let's go ahead and assemble that. And there's the object code for each instruction. To make sure this is correct, I put these values into a disassembler, and we'll see if we get the right instructions. As you can see, all the values are the same that I've put in there, and you can see the outcome on the right. and we get all the same instructions. And you'll notice the jump instruction, we're jumping back to the third instruction. Thank you.